Machine learning algorithms are categorized into three main categories: supervised, unsupervised, and reinforcement learning. Up till now, we have looked into supervised learning, where in the given data set you have your class label or a target variable present. In unsupervised learning, all you have is set of features. You don't know about your target variable or a class label. Using this data set, we try to identify the underlying structure in that data, or we sometimes try to find the clusters in that data, and we can make useful predictions out of it. K-means is a very popular clustering algorithm, and that's what we are going to look into today. As usual, the tutorial will be in three parts. The first part is theory, then coding, and then exercise. Let's say you have a data set like this where x and y axis represent the two different features, and you want to identify clusters in this data set. Now, when the data set is given to you, you don't have any information on target variables, so you don't know what you're looking for. All you're trying to do is identify some structure into it, and one way of looking into this is these two clusters. Just by visual examination, we can say that this data set has these two clusters. And K-means helps you identify these clusters. Now, K in K-means is a free parameter, wherein before you start the algorithm, you have to tell the algorithm what is the value of K that you are looking for. Here, K is equal to 2. So let's say you have this data set, you start with K is equal to 2. And the first step is to identify two random points which you consider as the center of those two clusters. We call them centroids as well. So you just put two random points here. If your K was, let's say, 3, then you will put 3 random points, okay? And these could be placed anywhere in this 2D place, doesn't matter. Next step is to identify the distance of each of these data points from these centroids. So for example, this data point is more near to this centroid, hence we'll say it belongs to red cluster. Whereas this data point is more near to green, so we'll say this belongs to green cluster. The simple mathematical way to identify the distance is to draw this kind of line, connecting the line between those two centroids, and then draw a perpendicular line. Anything on the left hand side is red cluster, on right hand side is green cluster. So there you go, you already have your two imperfect clunky clusters, and now we try to improve these clusters. Okay, so you already got your two clusters. Now we'll make them better and better at every stage. And the way you do that is you will try to adjust the centroids for these two clusters. For example, for this red cluster, which is these 4 data points, you will try to find the center of gravity almost, and you'll put the red centroid there, and you do the same thing for green one. So you get this when you make the adjustment, and now you repeat the same process again. You recompute the distance of each of these points from these centroids, and then if the point is more near to red, you put them in a red cluster, otherwise you put it in a green cluster. Okay, so you repeat the same method, and see, now these points got changed from green to red, so they're more near to red, that's why they are in red cluster. And you keep on repeating this process. You just recalculate your centroids, then recalculate the distance of individual data points from these centroids, and readjust the clusters until the point that none of the data points change the cluster. So here right now, see, there is only one green which is changing its cluster, so now it's in red. But after this we are done. Even if you try to recompute everything, none of these data points will change their position, hence we can say that this is final. So these are now my final clusters. Now the most important point here is you need to supply K to your algorithm, but what is a good number on K? Because here we have two-dimensional space. In reality, you will have so many features, and it is hard to visualize that data on a scatter plot. So which K should you start with? Well, there is a technique called elbow method, okay, and we'll look into it. But just to look at our data set, we started with 2 clusters, but someone might say, oh, no, these are actually 4 clusters. Third person might say, oh, they are actually 6 clusters. So you can see like different people might interpret these things in a different way, and your job is to find out the best possible k number, okay, and that technique is called elbow method. And the way that method works is you start with some k, okay, so let's say we start with k is equal to 2, and we try to compute sum of squared error. What it means is for each of the clusters, you try to compute the distance of individual data points from the centroid, you square it, and then you sum it up. So for this cluster, we got sum of squared error 1. Similarly, for the second cluster, you will get the error number 2. And you do that for all your cluster, and in the end you get the total sum of squared errors. Now we do square just to handle negate value. There is nothing more than that, okay. So now we computed SSE for k equal to 2. You repeat the same process for k equal to 3, 4, and so on, okay. And once you have that number, you draw a plot like this. Here I have k going from 1 to 11, and then on the y-axis I have sum of squared error. You'll realize that as you increase number of clusters, it will decrease the error. Now it's kind of intuitive if you think about it. At some point, you can consider all your data points as one cluster individual, where your sum of square error becomes almost 0, okay. So let's assume we have only 11 data points. At 11 value of k, the error will become 0, okay. So error will keep on reducing, and the general guideline is to find out an elbow. So the elbow is on this chart, this point is sort of like an elbow, okay. So here is a good cluster number, okay. So for example, for whatever the data set this chart is representing, a good k number would be 4. All right, so that was an elbow technique. Let's get into Python coding now. All right, so the problem we are going to solve today is cluster this particular data set where you have age and income of different people. Now by clustering these data points into various groups, what you're trying to find out is some characteristics of these groups. Maybe the group belongs to a particular region in US where the salaries are higher or the salaries are lower, or maybe that group belongs to a certain profession where the salaries are higher versus less, okay. So you try to identify some characteristics of these groups. So right now we have just name, age, and income, and first thing I'm going to do is import that data set into pandas data frame. So here you can see that I imported essential libraries, and then I have my data frame ready with that. And since the data set is simple enough, I will first try to plot it on a scatter plot, okay. So when you plot it on a scatter plot, of course I don't want to include name, I just want to plot the age against the income. So df dot age, df income in dollar. I'll just use the same convention. You can use dot also, but since there is a bracket here, I'll use the same convention. Okay, when you plot this on scatter chart, you can kind of see 3 clusters, 1, 2, and 3. So for this particular case, choosing k is pretty straightforward. So I will use KMeans. So KMeans is something we imported here, okay. And of course you need to specify your k, which is n underscore clusters. And by the way, in Jupyter Notebook, when you type something and when you hit tab, it will autocomplete, okay. So it creates this KMeans object for you, and it has all these default parameters. You can tweak all these parameters later, but I'm just trusting on the default parameters. The second step is fit and predict. So in previous supervised learning algorithms, we used to do fit and then calculate the score. Here I'm just directly doing fit and predict. So fit and predict what? Okay, I'm going to fit and predict the data frame excluding the name column, because name column is string and it's not gonna be useful in our numeric computation, so I want to ignore it. All right, so you do fit and predict, and what you get back is y predicted. So now what this statement did is it ran K-means algorithm on age and income, which is this scatter plot, and it computed the cluster as per our criteria, where we told algorithm to identify 3 clusters somehow. Okay, and it did it. It just assigned them different labels. So you can see 3 clusters, 0, 1 and 2. Now visualizing this array is not very much fun. So what we want to do is we want to plot it again on a scatter plot so that we can see what kind of clustering result did it produce. Okay, so I am in my data frame. I am going to append this particular column so that my data frame looks like this. So now this is a little better, where I can see these two guys belong to same group, these two belong to same group, and so on. But it is still not as good as scatter plot. Okay, so let's do this. Plot dot scatter plot. All right, now what we need to do is we need to separate these 3 clusters into 3 different data frames. So let me do that. df1 is equal to df dot cluster is equal to 0. Okay, so what this is doing is it's returning all the rows from data frame where cluster is 0, and the second one will be this, and the third one will be this. So now we have 3 different data frames, each belonging to one cluster, and I want to plot these 3 data frames onto one scatter plot. Okay, now just to save some time, let me just copy paste the code here. Okay, I will come at this little later, but see, 3 different data frames, and we are plotting these data frames into different color. Okay, so cluster 0 is green, then red and black. Let's see how that looks. Okay, so oh, I made a mistake here. I had a typo. Good. All right, so I see a scatter plot here, but there is a little problem. So this red cluster looks okay, but there is a problem with these 2 clusters. They are not grouped correctly. So this problem happened because our scaling is not right. Our y-axis is scaled from, let's say, 40,000 to 160,000, and the range of x-axis is pretty narrow. See, it's like hardly 20 versus here is 120,000. So when you don't scale your features properly, you might get into this problem. That's why we need to do some pre-processing and use MinMaxScaler to scale these 2 features, and then only we can run our algorithm. All right, so we are going to use MinMaxScaler. So the way you do it is you will say scaler is MinMaxScaler, and this is something, if you already noticed, we imported here. Okay, all right, so scaler is this, and scalar dot fit df. So now I want to fit first the income. All right, so my scalar, MinMaxScaler, will try to make the scale 0 to 1. So after I'm done with my scaling, I will have a scale of 0 to 1 on y as well as x axis. All right, so df, let me just copy paste this guy here, is equal to scalar dot transform. Okay, so now scalar will scale the income feature. All right, so df this. Okay, let's see how that did it. So you can see that the income is scaled, right? It's like, say, 0.21, 0.38 and so on. So it is in a range of 1 to 0. You will not see any value outside 0 to 1 range. We want to do the same thing for our age also. Okay, so let's do that. Scalar dot fit df dot age. df dot age is equal to scalar dot transform df dot age, and then we print our df, and you can see the age is also scaled. Okay, I have this extra column because I made a mistake previously, but you can ignore that. You can ignore cluster also. So we have age and income features properly scaled now. Okay, and even if you plot these onto scatter plot, they will look, structure wise at least, they will look like this. Okay, all right, so the next step is to use K-means algorithm once again to train our scale data set. So it's gonna be fun now. Let's see what scaling can give us. And as usual, y predicted is equal to km dot fit and predict. So again, I started with 3 clusters, and I'm using I'm just fitting my scale data. Age, income. All right, and let's see my y predicted. So it predicted some values which yet don't know how good they are. So I will just do cluster is equal to y predicted. I will also just drop the column that we typoed, and then let's look at df. Okay, in place is equal to true. Okay, so now this is my new clustering result. Let's plot this onto our scatter plot. I'm just going to remove this for now. Now you can see that I have a pretty good cluster. See, black, green and red, they look very nicely formed. One of the things we studied in our theory section was centroids. So if you look at KM, which is your train K-means model, that has a variable called cluster centers, and these centers are basically your centroids. Okay, so this is X, this is Y. So this is the first centroid of your first cluster, second centroid and third centroid. And if we can plot this into a scatter plot, it can give a nice visualization to us, right? So plt.scatter, So first let's plot x-axis. Okay, so x-axis for this will be, it will be what? Okay, so using this syntax you can say I want to go through all the rows, which is 3 rows here, and then the 0 means first column, which is this. Okay, and your y is your first column. And just to differentiate them with regular data points, I will use some spatial marker and color. So you can see that these are the centers of my clusters. All right, let's look into now elbow plot method. See, this data set was simple, but when you're trying to solve a real life problem, you will come across data set which will have like 20 features. It will be hard to plot it on a scatter plot and it will just get messy. And you'll be like, what do I do now? Well, you use your elbow plot method. So in elbow plot, as we saw in theory, we go through number of k's. Okay, so let's say we'll go from k equal to 1 to 10 in our case. Okay, and then we try to calculate SSE, which is sum of square error, and then plot them and try to find this elbow. So let's define our k range. Let's say I want to do 1 to 10. This will be 1 to 9, but whatever. Okay, and then sum of squared error is an array. So for k is equal to 1, you will find SSE, k equal to 2, you will find SSE, you will store all of that into this array and then use matplotlib to plot the result. Okay, so for k in k range, so I'm just going through 1 to 9, and then each iteration I create a new model with clusters equal to k, and then I call fit. Okay, and what do I try to fit? Okay, I try to fit my data frame, but I use this syntax because my data frame has name column. I don't want to use name column. All right, you'll be like, what the heck this guy is doing all the time using this crazy syntax, but that's to avoid name. If you want, you can just create a new data frame, just drop name column, that is fine too. And all right, so now what is my sum of square error? How do I get that? When you call km.fit, after that on your k-means there is a parameter called inertia that will give you the sum of square error, and that error we want to just append it to our array that we have. All right, that was pretty fast because our data set is very small. Okay, let's see what is SSE. So SSE, you can see that sum of square error was very high initially, then it kept on reducing, and now let's plot this guy into nice chart. Okay, when you do that, you get our elbow plot. Remember elbow plot? Elbow. All right, where is my elbow? Where is my elbow? Okay, here is my elbow. You can see that k is equal to 3 for my elbow, and that's what happened. See, I have 3 clusters. For exercise, we are going to use our iris flower dataset from sklearn library, and what you have to do is use petal length and width features. Just drop sepal length and width because it makes your clustering a little bit difficult. So just drop these 2 features for simplicity. Use the petal length and width features and try to form clusters in that data set. Now that data set has a class label in the target variable, but you should just ignore it. Okay, you can use that just to confirm your results. And in the end, you will draw an elbow plot to find out the optimal value of k. All right, so just do the exercise, post your results, into the video comments below. Also, I have provided a link of Jupyter Notebook used in this tutorial in the video description. So look at it. When you go towards the end, you will find the exercise sections. Also, don't forget to give it a thumbs up if you like the content of this tutorial. You can also share it with your friends.